that doesn't look nice. And although this particular one doesn't have variables, a lot of them will, so it's not like you can just type it into your calculator. I'm starting with a numerical example so we can wrap our head around a procedure. There's two different ways that I could teach you to do this. One of them, though, is much more useful and can be used for the long haul. Like once you get to pre-calc, problems can get pretty ugly if you use the one method, so I'm just not going to show that to you at all, and I'm just going to show you the clearing fractions method. So here's what you will think to yourself. If you see a fraction within a fraction, and in this case there's actually 3 fractions within the larger fraction, right? The overall numerator is here. There's your big division sign, and there's your overall denominator. But within the numerator we have 2 mini fractions, and within the denominator we have another mini fraction. You want to find the least common denominator of all mini fractions within the problem. So our denominators are 9, 18, and 3. What's the least common denominator of 9, 18, and 3? No. That's a factor. For example, if I had 3 fractions and I was trying to add them together, and their mini denominators were 9, 18, and 3, what would I have to make the least common denominator? 18. Does that make sense? That's what we mean by the least common denominator of all of those. So it would be 18. Once you find that, you multiply by that on the top, and you multiply that on the bottom. Because that is a common denominator option for all of them, you're going to see exactly how this clears the fraction when we distribute it through. When you distribute it through the numerator, 1/9 times 18 is 18 ninths. 18 ninths is the same thing as what? 2. 1/18 times 18 is 18 eighteenths, which is 1. Fractions in the numerator cleared. Does that make sense? 18 times 1/3 is 18 thirds. 18 thirds is 6. There we are. 3/6, 1/2, no longer complex. Okay? Exercise 2, part A is another numerical one. I'm going to bypass that one because it's going to be more of the same. But if I look at, let's even jump right to C. My mini denominators are 8, 4x, 2x, and 4. If those were all denominators of fractions, what would the least common denominator, Owen, be? Nope. If I had to get these all to be the same thing, 8 wouldn't work because there's no way to get this to 8 because I have an x there that I can't just erase. 8x, does everybody see that? 8x would be the least common, because this would need to be multiplied by x, this by 2, this times 4, and this by 2x. And then they would all be 8x. 8x is the least common denominator, so I'm going to multiply the numerator by 8x and the denominator by 8x. I'm multiplying by something over itself, so I'm multiplying by 1, but I'm going to change the appearance without changing the value. So in my numerator, 3/8 times 8x is 24x over 8, right? Does that make sense, everybody? 3/8 times 8x is 24x over 8, which is what? 3x. Some of you might also envision like the 8s canceling. 8 and 8 cancels. So I would just leave a 3x if that's more helpful. 8x times 1 over 4x is 8x over 4x, which is what? 2. No, just 2. 8x over 4x is just 2. Over. If I distribute, 7 over 2x times 8x is 56x over 2x. what'd you say? 28. 56x over 2x is 28. And then when I distribute there, 3/4 times 8x is 24x over 4. 6x. Agreed? Complexity is gone. I no longer have many fractions with fractions, because if I'm picking something that's a least common denominator to all of them, it will essentially cancel out all of their denominators. Okay? Now, with that, can this be simplified further? Like this one was 3/6. That was an easy jump to 1/2. This one's a little bit more complicated, because if I want to try to factor or to simplify it, I would have to factor it. The numerator is not factorable, but I can take 2 out of that denominator. I don't know if anything's going to happen, but if I take out a 2, I'm left with 14 plus 3x. Did that help? No. So your final answer, if it was a multiple choice, could be this, or it could be that. Where's down here? This one? Do what to it? So you reduce the 3x with the 6x and the 2 with the 28. Someone share with him why that's a big no-no. Because he crossed out pieces of polynomials. You did one piece here with this one piece. If it was factors of 3x and 2 and factors of 28 and 6x, then you could do that, because factors reduce the whole factors. Does that make sense? Okay, no, it's tempting, I know it, but you can't do that. All right, gets a little bit trickier, because now our denominators are polynomials, no longer monomials. Anytime you're starting with polynomials, you have to start by factoring. So in my numerator here, nothing's factorable, nothing's factorable. In my denominator, I can factor, really I want to factor the denominators is my biggest thing, because I want to see what the least common denominator is. So I would do that x minus 4 and x plus 2 and kind of replace that denominator. So I have 3 mini fractions within the larger fraction. There's a denominator of x plus 2. There's a mini denominator of x minus 4. And there's a mini denominator of x minus 4, x plus 2. What would be the least common denominator of all 3 of those? If they had to be all the same, what would they be? Kate. I'm going to do it this way. If you had 3 fractions, all with these 3 different denominators, and you had to like add them all together, let's put a 1 up top just for fun. What would this one need? An x minus 4. What would this one need? Okay, what would this one need? Nothing, right? You don't have to give it a 1. So now, once you give everything, all of those things, what is the denominator of all 3 of them? They all have a denominator of x minus 4, x plus 2. So that's your least common denominator. So up top, I'm going to multiply by an x minus 4, x plus 2. On the bottom, I'm going to multiply by an x minus 4, x plus 2. So in my numerator, I have to take this and I have to distribute it. When I distribute it to the first fraction, what cancels? This denominator has an x plus 2, and I'm multiplying it by an x plus 2, so those will cancel. And I'm left with just the 4 and an x minus 4. because that canceled. When I distribute that same thing to the second fraction, the x minus 4 denominator will cancel with this x minus 4, leaving what, Jason? When I multiply this times that, the x minus 4 is canceled, and so I'm left with a and a 2. Complexity is gone in the numerator anyway. In my denominator, when I take this and multiply it by the only mini fraction that's there, the entire denominator cancels with this entire thing, leaving just a 12x minus 24. So now that that complexity is gone, I just need to simplify the numerator. So distributing my 4 and my 2. Combining like terms will give me 6x minus 12. And I can factor both of them. I'm not sure if it's going to help yet, but in the numerator I can pull out a 6. And in the denominator I can pull out a 12. Was that helpful? What do you think, Lucas B? Can I do anything from here? What do they have in common that I can cross out? Okay. And then 6 over 12? 1/2. So that whole thing just ends up being a half. Okay, so let's just do one more together on the bottom here. Factor out your denominator so we can see what the least common denominator would be. And this factors into what? Take a minute, try to factor that. Faye, what does that factor into? Good, x plus 6, x plus 2. So I have 3 mini denominators, x plus 6, x plus 2, and x plus 6x plus 2. So Natalie, what would be the least common denominator of all 3 of those? Right, and then that's what you multiply by. So up top, x plus 6x plus 2. On the bottom, x plus 6, x plus 2. The numerator is a binomial, so I'm going to have to distribute that one. The denominator is not, so I don't have to distribute. But so let's go up top. And when I multiply this by my first fraction, so just ignore everything else. Angie, what's going to cancel when I do that? And what's left then? Not x over x plus 2. The over part should be gone because your denominator cancels, right? So it's just x plus 2. Okay. Good. Minus, when I distribute here, up top, Morgan, what cancels? And what's left? Beautiful. Good, good, good. Over. And on my denominator, it's just one fraction. When I multiply that by the fraction, Georgia, what cancels? And so what's left? Perfect. So I know that's a lengthy process. It's pretty ugly to look at. Hopefully you can follow that. Once you're here, it should be pretty straightforward. Simplify your numerator, factor everything, see if it cancels. So when I distribute up top, I get x squared plus 2x distributing my negative 1, I get minus x minus 6. My numerator combines to x squared plus x minus 6. And I believe both of those are factorable. I have an x plus 3x minus 2 and an x plus 2, x minus 2. Vince, does anything cancel? Yep. And there's your final answer. Okay, two things coming around. Spiral. And then your homework. Jason, you assumed your secretary role like a champ. You just took it in stride. I'm impressed.